There is a mountain in Peru that looks like someone attacked it with thousands of holes. Not 10, not 100, 5,200. They stretch across the landscape for roughly a mile and a half, arranged in rows, clusters, and strangely precise sections. From the ground, they can look almost meaningless, just pits, one after another. But climb above them, and something changes. The holes stop looking random. They begin to form patterns, groups, rows, numbers, an enormous arrangement carved into the landscape by people who left behind almost no explanation of what they were doing. For decades, archaeologists could see the holes, but they couldn't answer the simplest question: why? Were they storage pits, water collectors, defensive structures, agricultural installations? Some even imagined explanations far removed from conventional archaeology. But then researchers returned with something earlier archaeologists didn't have: drones, high-resolution aerial mapping, sediment analysis, and a way of looking at the mountain not as a collection of holes, but as a system. And what they found suggested something remarkable. The people who created this landscape may not have been building a fortress. They may not have been worshiping the gods. They may have been doing something much more ordinary, something every civilization eventually needs to do. They were keeping track of goods, of exchanges, of quantities, perhaps even of obligations. A kind of accounting system written not on paper, but directly into the earth. And if that interpretation is correct, then this strange mountain in Peru may preserve something far more important than a mystery. It may preserve evidence of how an indigenous society organized an economy before the arrival of Europeans. So, who built the 5,200 holes? And why would anyone carve thousands of them into a mountain? To answer that, we have to travel back to a world before the Inca Empire ruled the Andes. A world of traders, farmers, fishermen, merchants, administrators, and a civilization whose greatest invention may not have been a monument at all. It may have been information. The Pisco Valley of southern Peru is not the landscape most people imagine when they hear the word civilization. There are no lush European-style fields stretching toward the horizon, no broad rivers winding through green forests, no enormous stone temples dominating the skyline. Instead, the landscape is harsh, dry, dusty, sun-baked. The Andes rise inland, while the Pacific lies to the west. Between them is a landscape where water is everything, where a river can determine whether a community survives, where agriculture depends on irrigation, and where the desert can preserve traces of human activity for centuries. Somewhere within this landscape stands Monte Sierpe, Serpent Mountain. The name sounds almost mythical, but the mystery here is completely real. Across the slope are thousands of artificial-looking depressions, each generally around 1 to 2 meters across and roughly half a meter to a meter deep. They aren't arranged as one giant uniform grid. Instead, they appear in different sections. Some contain stone-lined edges, others don't. Some groups contain strikingly regular rows, others are organized differently. The entire formation extends for approximately 1.5 kilometers, and there are around 5,200 holes. That number alone is difficult to visualize. Imagine standing on the mountain and seeing hole after hole stretching beyond your field of vision. Then imagine continuing and continuing for more than a kilometer. Now imagine that every one of those depressions had to be made by human beings without modern excavation equipment. Someone had to decide where each hole would go. Someone had to dig it. Someone had to maintain the pattern, and someone had to know why. That last part is the problem, because the builders left us no instruction manual, No inscription saying, "This is what the holes are for." There is no ancient sign explaining the system. No surviving document from the people who created it. And that is what makes archaeology so fascinating. Sometimes the most difficult questions aren't about finding something. They're about understanding something you can already see. Monte Sierpe was photographed from the air as early as the 20th century, but the full organization of the site remained difficult to understand. The modern research breakthrough came from detailed drone imagery that allowed archaeologists to examine the entire arrangement at a much finer scale. And once they could finally see the whole thing, the mountain began to look less like chaos and more like a machine designed by people. To understand Monte Sierpe, we first have to forget the Inca Empire for a moment, because the Inca were not the beginning of civilization in Peru. When Europeans arrived in South America in the 16th century, the Inca Empire was enormous. It stretched along much of the Andes. Its roads crossed mountains. Its administrators moved people and goods across enormous distances. Its rulers commanded armies. Its engineers built terraces, bridges, and cities. But the Inca inherited a world that was already ancient. For thousands of years, societies had been developing along the Pacific coast and in the Andes. They experimented with agriculture, irrigation, trade, architecture, religion, and systems for organizing labor. The Pisco Valley was part of that long history, and between roughly AD 1000 and 1400, before the Inca conquest of the region, powerful local societies controlled parts of the central Peruvian coast. Among them were the people associated with the Chincha kingdom. This is where Monte Sierpe becomes particularly interesting. The site appears to date at least to the late Intermediate period, roughly AD 1000 to 1400, and researchers believe it continued to be used after the Inca incorporated the region during the 15th century. That means the holes weren't necessarily the product of one moment. They may represent a system that evolved. And that distinction matters, because ancient landscapes are rarely static. A building can change purpose. A road can become a boundary. A temple can become a political center. A marketplace can become an administrative station. And Monte Sierpe may have experienced exactly that kind of transformation. Imagine the Pisco Valley around 1,000 years ago. The desert is still here. The mountains are still here. But the landscape is alive. Irrigated fields spread around the river. Farmers grow crops. Fishermen bring resources inland from the Pacific. Craft specialists produce textiles and other goods. Traders move between ecological zones. And somewhere within this network, people need to exchange things. That sounds simple. But in the ancient Andes, exchange was not simply a matter of handing someone a coin. There was no modern banking system, no standardized paper currency, no supermarket barcode, no spreadsheet. Yet complex societies still had to answer the same questions we face today. How much? Who brought it? Who received it? What is owed? What has already been delivered? What remains? And perhaps most importantly, how do you remember all of it? That question leads directly to Monte Sierpe. When we picture an ancient marketplace, we often imagine something familiar. A merchant sits behind a table. A customer approaches. They negotiate. Coins change hands. Transaction complete. But ancient Andean economies did not operate according to that simple model. Exchange could involve goods, labor, obligations, and relationships. A person might produce maize. Another might produce cotton. Another might have access to resources from the coast. Another might specialize in crafts. Communities could exchange products across ecological zones. And in a place like the Andes, geography itself created enormous economic diversity. Within relatively short distances, elevation changes dramatically. Different environments produce different resources. The coast offers marine products, river valleys support agriculture, higher elevations provide other crops and materials. This created opportunities for exchange. But exchange creates a problem. The larger the network becomes, the harder it becomes to remember who owes what. That is where record-keeping becomes essential, and this is something the Inca later became extraordinarily sophisticated at. They used quipu. A quipu was not a book. It was not writing in the alphabetic sense. It was a system of chords and knots used for recording information. Different colors, chord arrangements, knot types, and positions could encode information. The exact meaning of every aspect of the system is still not completely understood, but there is no question that quipu were central to Inca administration. And now consider Monte Sierpe. Thousands of physical units, organized into sections, repeated numerical patterns, different blocks, different arrangements, a landscape that appears to contain information. This doesn't prove that Monte Sierpe was literally a giant quipu. It doesn't mean the Incas looked at the mountain and read it like a modern accountant reads a spreadsheet. But the structural comparison is intriguing. Researchers found patterns in some sections that appear numerically organized, including repeated rows with consistent numbers of holes. One example contains at least 9 consecutive rows of 8 holes. Another contains groups of 7 and 8 holes, totaling 50. That's not proof of accounting, but it changes the question. Instead of asking, "Why are there holes here?" we can ask, "Why are the holes organized this way?" And that is a much more powerful question. For decades, researchers considered many possibilities. Perhaps the holes stored something. Perhaps they collected water. Perhaps they were connected with agriculture. Perhaps they had a defensive function. Perhaps they captured moisture from fog. The range of hypotheses tells us something important. The site doesn't obviously resemble a familiar archaeological structure. It isn't a pyramid. It isn't a temple. It isn't a conventional fortress. It isn't a cemetery. It isn't a road. It's something else. And that made interpretation extraordinarily difficult. One of the biggest problems was visibility. From the ground, the site can be overwhelming. You're too close to see the entire pattern. Walk among the holes and they seem like individual features. One, then another, then another. But archaeology often depends on seeing relationships. A single wall may mean very little. 1,000 walls arranged into streets can reveal a city. A single hole means almost nothing. 5,000 holes arranged according to a system could mean almost anything, or something very specific. The researchers needed a better view, and eventually, technology gave them one. There is something almost poetic about the technology used to investigate an ancient landscape. The builders of Monte Sierpe had no aircraft, no satellites, no digital cameras, no GPS, yet they created something that could only truly be appreciated from above. For generations, archaeologists had to work with limited aerial imagery. Now a drone could fly directly over the site, back and forth, methodically, capturing thousands of high-resolution images. Those images could then be combined into detailed maps. The effect was dramatic. The mountain became legible. Instead of approximately 5,000 isolated pits, researchers could study a connected system. They could divide the formation into sections, compare one group with another, measure distances, count holes, identify repeated patterns. The researchers identified at least around 60 sections in their detailed imagery, while noting that the exact boundaries of sections can sometimes be subjective. And suddenly, the holes started behaving like numbers, not just shapes. Numbers 8, 7, 50, repeated sequences, organized groups. That was the first major clue. But there was still a problem. A pattern doesn't automatically tell you what something was used for. You can find patterns in almost anything. Nature creates patterns. So do random processes. The archaeologists needed evidence of human activity. They needed to know what had actually been inside the holes, and that meant going down into the dirt. Archaeology often looks glamorous from the outside. Ancient temples, golden artifacts, stone statues, underwater cities. But some of the most important discoveries come from something that looks almost worthless. Dust, soil, sediment, tiny fragments invisible to the naked eye. Inside the Monte Sierpe holes, sediment had accumulated over centuries, and sediment can act like a time capsule. Plants leave microscopic traces, pollen, phytoliths, other botanical remains. If you know how to look for them, they can reveal what kinds of plants were present. The research team analyzed sediment samples from the site, and they found evidence associated with crops and wild plants. That doesn't mean every hole contained a pile of maize. It doesn't mean the holes were simply storage bins. But it provides something crucial: evidence that the landscape was connected to plant products and human activity. Now imagine the ancient marketplace. The desert wind moves across the valley. People arrive carrying agricultural products, bundles of material, baskets, food, fibers, goods produced in different ecological zones. The holes are no longer simply holes. They become potential units, spaces that could organize goods, quantities, groups, exchanges. And suddenly, the mountain begins to look like an economic landscape. This is where the new interpretation becomes especially interesting. The researchers propose that Monte Sierpe may have functioned as a local indigenous system of accounting and exchange. The idea is not simply that people stored objects in holes, it is more sophisticated. Imagine a place where different communities meet. One group arrives with maize, another with cotton, another with other agricultural or wild plant resources. Instead of negotiating every exchange from scratch, standardized physical spaces could help organize quantities. A section of holes could represent one category, another section, another category. Numbers of holes could represent quantities. Groups could be counted. Goods could be temporarily placed. Transactions could be organized. In this interpretation, the holes weren't the commodity. They were the framework, the infrastructure of exchange. This would be a form of social technology, and that phrase is important because technology doesn't have to mean metal machines. A road is technology. A calendar is technology. A writing system is technology. A standardized weight is technology. A system for counting goods is technology. Monte Sierpe may represent technology made from landscape itself. But we need to be careful. The archaeological evidence does not allow us to reconstruct every transaction that happened there. We don't know the names of merchants. We don't know exactly what each section represented. We don't possess an ancient manual explaining the system, and the researchers explicitly describe the site's function as uncertain. So this is not a story about archaeologists discovering an ancient receipt. It's a story about evidence converging, patterns, plants, location, historical context, and comparison with known Andean systems of accounting. Together, they create a hypothesis, and that hypothesis gets even more interesting when the Inca arrive. By the 15th century, a new political power was spreading rapidly through the Andes, the Inca. Their expansion transformed the political map of Western South America. But conquest did not necessarily mean destroying everything that came before. The Inca were extraordinarily skilled at absorbing existing systems. Local leaders could be incorporated. Roads could be reused. Administrative centers could be expanded. Existing economic practices could be adapted. And Monte Sierpe appears to have survived into this period. The research dates its earlier use to at least the late Intermediate period and indicates continued use during the Inca period, approximately AD 1400 to 1532. That raises a fascinating possibility. Maybe the Inca didn't invent the system. Maybe they inherited it. Imagine an Inca administrator arriving in the Pisco Valley. He sees the mountain, thousands of holes, organized sections, a system already embedded in local society. Instead of destroying it, he recognizes its usefulness, because empires have one universal problem. They need information. How many people live here? How much maize is produced? How much cotton? How much labor can be provided? How much has already been delivered? How much is still owed? The larger the empire becomes, the more important those questions become. And the Inca had an answer: records. A quipu can look deceptively simple: a cord, some knots, several strings. Nothing like a modern ledger, but simplicity can be misleading. The Inca used quipu as part of their administrative system, and specialists known as quipu kamayuk were responsible for working with these records. The exact nature of the information encoded in every surviving quipu remains a major area of research, but numbers could be represented. And that is where Monte Sierpe becomes fascinating. Researchers noticed numerical structures in the arrangement of the holes that they argue have potential parallels with the organization of quipu. Think about what that means. Not that a mountain became a giant piece of string, but that different technologies can solve the same problem. How do you turn quantities into organized information? A quipu does it with cords. Monte Sierpe may have done it with space. One system uses knots, the other uses holes. One can travel with an administrator, the other is fixed to a landscape. Both potentially transform abstract quantities into something physical. And if that comparison is correct, it tells us something profound. Ancient Andean societies didn't need alphabetic writing to build complex administrative systems. They developed other ways of making information visible. Now let's return to the 5,200 holes. Imagine looking at the entire formation from above. The holes stretch across the mountain, but they aren't simply evenly spaced. There are clusters, sections, different construction styles, different numerical arrangements. The researchers identified repeated structures within portions of the site, and this is where the phrase "ancient spreadsheet" becomes tempting. It is an excellent metaphor, but it should remain a metaphor because a spreadsheet has columns and formulas. Monte Sierpe doesn't. What it may have had was something more fundamental: standardized physical units for organizing information. Imagine a community arrives. Their goods are measured according to a shared system. The goods correspond to spaces. The spaces correspond to quantities. The quantities correspond to exchange. Now the landscape itself becomes part of the economy. The mountain doesn't merely overlook the marketplace, it participates in it. Every hole can become a unit. Every row can become a grouping. Every section can become a category. The physical arrangement helps people remember what has happened. And that would solve a fundamental problem of large-scale exchange. Human memory is limited. Systems are not. But there is a danger in archaeological storytelling. We can become so fascinated by the structure that we forget the people. 5,200 holes sounds abstract. 5,200 acts of labor do not. Someone had to dig them. Probably many someones. Picture a worker standing on the dry hillside. The sun is high. The ground is hard. There is no excavator, No metal drilling machine, no modern survey equipment, just tools, hands, coordination, and a plan. The first hole is made, then another, and another. A line begins to appear. Weeks become months. Perhaps generations become involved. The site grows, and eventually the mountain carries the accumulated work of an entire community. This is what monumental construction often hides: the human cost. We tend to think of ancient monuments as the creations of kings, pharaohs, emperors, Inca rulers. But a ruler cannot build anything alone. A state may command, but people build, and Monte Sierpe may therefore be evidence not simply of political authority, but of collective organization. To understand why a system of exchange could become so important here, we need to look at the broader Chincha world. The Chincha kingdom occupied an important region of the central Peruvian coast. Its position connected agricultural valleys and coastal resources. Trade could move between ecological zones, and that meant information had value. Knowing where goods came from mattered. Knowing quantities mattered. Knowing obligations mattered. A prosperous trading system cannot operate efficiently if nobody knows what is being exchanged. The Pisco Valley was therefore more than an isolated desert. It was part of a network, and Monte Sierpe may have been one of the places where that network became physically organized. Imagine approaching the site centuries ago. The mountain is not empty. People are arriving. Goods are being moved. Conversations overlap. Animals carry loads. Agricultural products are being sorted. People compare quantities. An administrator watches. A trader waits. A community representative negotiates. The scene is not necessarily spectacular. There may be no king standing on a throne, no army, no monumental ceremony, just economic life. And that is precisely why the site is so important, because archaeology often tells us about rulers. Monte Sierpe may tell us about systems. This is one of the biggest questions. If the purpose was exchange, why put the system here? Why not build it beside a river? Why not inside a settlement? Why this particular landscape? The answer may involve geography. Monte Sierpe occupies a location within the broader Pisco Valley landscape and sits in relation to ancient routes and administrative centers. That position could have made it useful as a meeting point, but we shouldn't pretend the question is solved. The site may have had more than one function. That is common in archaeology. A structure can begin as one thing and become another. A market can become an administrative facility. A storage area can become a tax collection point. A local innovation can be adopted by an empire. This is perhaps the most interesting possibility. Monte Sierpe may not have had a single purpose for its entire existence. It may have evolved. And if so, the 5,200 holes are not one moment frozen in stone. They are a record of changing society. Now imagine the arrival of the Inca state. The local economy already exists. The local people already know the landscape. The Inca don't necessarily need to invent an entirely new system. They need to integrate the region. And one of the most important mechanisms of the Inca state was the organization of labor and resources. Tribute did not simply mean handing over coins. There was no modern tax office. Communities contributed labor and goods within a highly organized political system. A local population could owe resources to the state: agricultural products, textiles, labor, other goods. That requires measurement, and measurement requires administration. If Monte Sierpe was already functioning as a system for organizing exchange, the Inca may have recognized its potential. The same physical infrastructure that once helped communities trade could potentially help an empire account for what communities provided. That is the central transformation suggested by the new research. Local exchange becomes imperial administration. A community invention is absorbed into a state system, and the mountain changes meaning. This is where the smallest evidence becomes some of the most powerful. Archaeologists can look at ancient landscapes and ask, what survived? Not everything survives. Wood rots, textiles decay, food disappears, people leave, but microscopic plant traces can remain. The research team's sediment analyses identified evidence of crops and wild plants, contributing to the interpretation that agricultural goods were involved in the site's activities. That matters because it moves the theory away from pure geometry. The holes aren't only arranged in interesting patterns, there are also biological traces connected with human activity. Now imagine the ancient goods, maize, plant fibers, other agricultural products. A person brings them, another person records them. The holes provide standardized physical spaces. The system becomes a meeting point between material goods and information.